Hello, everybody. So we're back once again with our live stream. I'm just making a quick check on the audio to see if all is good. Yeah, so we should be good with the audio. So today we're going to talk about lambdas, lambda functions, and in particular high order functions and lambdas. And these are special functions in Kotlin that it's a actually lambdas is a concept that is also available in other programming languages, and it's a very interesting concept. So I would start with the meaning of a lambda function, and to do so we're going to ask our ChatGPT friend describe a lambda function. Let's see. So a lambda function is an anonymous function that can be defined and passed as a value. It is often used for short pieces of code, especially in functional programming and when working with collections or asynchronous APIs. So that's an example of a lambda function, and it's especially useful in functional program when working with collections or with asynchronous functions. So for example, you have a square, you're passing an integer value, which is your number here, and you want to return another integer number, which is given by the square of that number, so number times number. And for example, you can print square 5 as and you will get output 25. Okay. So what it isn't state here is what is functional programming. So let's have a definition of this. Define this, also related to Kotlin. So functional programming is a paradigm based on the idea of treating computation as the evaluation of mathematical functions and avoiding changing state and mutable data. So it emphasizes pure functions, so there are no side effects. Immutability, so the result doesn't change because the result of a function, a mathematical function, should always be the same with the same input, of course. And first class functions are treated like variables. So okay, I think this is similar to what you have with get. Then you have high order functions, functions that take or return other functions. Okay, so you can take and return another function. We will see this also here. And then you have declarative style, focus on what to do and not how to do it. So for example, it says Kotlin supports both object-oriented and functional programming. It's a multi-paradigm language and making it great for combining OP structure with FP expressiveness. So you have first class and high order functions. You can assign functions to variables and pass them as arguments or return them. So what you can do is create a function, pass a function inside, and then, for example, you could compute that function that you're passing, like you're doing here. So you have a custom operate function that takes two numbers and one function, and it computes that function. And in this case, it will give the sum. Then you have lambda expressions. So yeah, this was high order functions. This is lambda expression. Lambda expression is what we have seen before. Then yeah, immutability is because Kotlin encourages the value over variable. And I don't know if you remember also the use of copy as a function of data classes. So that is also enforcing immutability. And also collections have immutable variants. So we have list of, which cannot be modified, and you have mutable lists that can be modified, so that are mutable. Then you have pure functions. What are pure functions? They are functions like you have here that gives the same output for the same input as we were saying before, and this has no side effects. And then you have collection operators. So operations like map, filter, fold are functional style programming tools, because you are, yeah, for example, inside a map, you are going to pass a function, which is called a predicate in Kotlin. I mean, they use this word, and the predicate is actually what you want to achieve. So imagine what we had here with high order functions. We were passing a predicate like x plus y, and this will do the same. So it will iterate through each element of the list, and then it will compute the predicate and return the result of the predicate. And then for filter, it will, instead of compute and return the result, it will just take some elements of the list based on the Boolean predicate that you pass. And I think we will see this later on with our guide. So what's the advantage of functional programming? It's to write cleaner and more precise code to avoid bugs from mutable state. And also the use of lambdas and higher order functions is more natural, because this way of mapping the list is very effective, very easy to read, and you could not do this in Java, for example, because I think, at least if they did not upgrade it, because you would need to make a for cycle. For example, this in can this be achieved? Let's read what they say. Yeah, it says that they can be achieved. So I am mistaken on this, but as you see with Java, you have a more verbose syntax, and you would need to use a stream. Let me just check when was introduced. So yeah, it was introduced in Java 8. Okay. And so not from the start as in Kotlin. Okay, let's go on and let's start reading this. So Kotlin functions are first class, which means they can be stored in variables and data structures, and can be passed as arguments to and returned from higher order functions. You can perform any operation of functions that are possible for other non-functional values. To facilitate this, Kotlin has Kotlin, yeah, to facilitate this as a statically typed programming language. What it does is it uses a family of function types to represent functions and provides a set of specialized language constructors such as lambda expressions. So let's start with high order functions. I don't know why they start with this, but okay. So high order function is a function that takes functions as parameters or returns a function. So a good example is the functional programming idiom fold. For collections, it takes an initial accumulator value and the combining function then builds its return value by consecutively combining the current accumulator value with each character element, replacing the accumulator value each time. So as you see here, combine accepts is a function that has to be passed to fold function, and it needs you need to pass r and t, and it will return r. So ACK is the accumulator, t, yeah, the type t is the next element, and it will return r. So your initial value is going to be set as initial, which is the value that you pass. Then there will be a for cycle in each element of the collection, and the accumulator will be calculated as combine accumulator, which is the initial value, and element, which is the element of the of the list of the iterated the iterated element of the list. And so basically element let's try this fold. Yeah, there's an example here. So in the code above the combine parameter, okay, we already read this. To call fold, you just need to pass an instance of the function to it as an argument, and the lambda expression, okay, as we just said. So here it's starting with 0, and when a lambda has parameters, they go first, followed by the arrow, followed by the arrow. So here we say pass 0 as our initial value, and then our accumulator and next element are going to be passed in this lambda. So the lambda has these two parameters, and then the lambda function will need to return a result which is of type r, right? So it has to be the same type as ACK, and in our case it's going to be an integer, because 0 and is an integer and ACK is an integer. So in this case we're good to go. And what it's doing here, it is using I, which is the element of the list, and it's adding it to 0. So if you do this, we are going to see the result of this in our code, and we're going to judge what this magical fold function is doing. So test lambda functions create this function and let's run it. Oh, there's still a bug here. I have also updated the IDE, but apparently I'm still having this issue. Okay, so let's start. Yeah, I is the element, as we said, of the list. We start with the initial value of 0, so we add 0 to 1, and we get 1. Then we see that ac is 1, and I is going to be 2, because it's the element, second element of the list. And then the result is going to be 3. So this is what the fold function does. It adds the accumulator, or yeah, the initial, yeah, it adds the accumulator to the, actually, yeah, this is how we have defined it. So it depends. You may want to change the behavior of your fold operation. You can do whatever you want in here, but as an example here, they're just adding the accumulator to the element of the list. And yeah, the accumulator is like the sum during the iterations. And a result is the return value. So actually, yeah, this is, as you see, what is, I want to see what it returns. So like, it returns an integer. So this function probably returns 15. Final result. Okay, yes, it's 15. Great. All right, so let's go on. Function types. Kotlin uses function types such as integer, yeah, arrow string. So integer parameter returns a string for declarations that deal with functions. So for example, val on click, you can also return nothing, like as a unit. These types have a special notation that corresponds to the signature of the functions, their parameters, and return values. All function types have parenthesized list of parameter types and return type. So like ABC denotes the type that represent functions that take as argument A and B and return C. All right. If the list can be empty, and you can return a unit if you want to the return type be omitted. Function types can have an optional receiver with a dot b and then c as a result, represent function that can be called on a receiver object a with a parameter b and a return value c. So what you may do is, for example, you want functions that can be called on a receiver object a with parameter b. So yeah, So B is your parameter and A is your receiver object. Let's so while it makes an example, let's read the last one. Suspending functions belong to a special kind of function that have a suspend modifier, such as suspend and then brackets and unit, so you can use suspend. The function type notation can optionally include names for the function parameters. So you could include names. These names can be used for documenting the meaning of parameters. Perfect. To specify that a function is a nullable, use parentheses. All right. Function types can also be omitted using parentheses. Sorry, can be combined using parentheses. All right. So here you are taking an integer and you are returning an integer to unit function. You can also give a function type an alternative name by using type alias. So yeah, that's also nice to know. Let's see, before going here, the example that was provided with A.B to C. For example, you have a string that with this defines a function that can be called on a string that takes int as parameter and returns a string. So hi dot repeated. Okay, so that's why. That's how it works. So a repeat word is the, for example, if you have you want to give both a string length and a number like 3, you can do this by specifying an integer argument to this function. So the string is the object receiver and the int is the argument that you're passing. So I will copy this example to our code. And here you need to specify 3 and you need to say ciao. There are several ways to obtain an instance of a function. Use a code block with a function literal in one of the following forms: a lambda expression, an anonymous function, so this is a lambda. This is an anonymous function that basically takes s as a string and returns an integer, and this will take s and do to int or null, otherwise it returns 0. Okay. Function literals with receivers can be used as values of function types with receiver. Use a callable reference to an existing declaration. So to instantiate a function type, you can use a top-level local member extension function, such as isodd, string to int, a top-level member or an extension property, so like the size of a list, and a constructor regex. These include bound callable references that point to a member of a particular instance, so foo to string. So this will take the reference to the toString method. So let's see here what I've done. We have a class returning, not returning, but inheriting from a function. And then this overrides the operator function. And then you have an init function that is a variable. So you're creating this object. You use instances of a custom class that implements a function type as an interface. The compiler can infer the function types for variables if there is enough information. So the infer type here is from int to int. Okay, but yeah, so in this case, it can infer the types. I think, yeah, it did infer the type also here. Whoa. Non-literal values of function types with and without a receiver are interchangeable. So the receiver can stand in for the first parameter and vice versa. For instance, a value of type A and B to C can be passed or assigned, where a value of type A dot B is expected and the other way around. Okay. I would instantiate in a function type recap. So yeah, lambda is like that. You may have an anonymous function like with the funky word. Okay. So I would point this out here. It's just a different syntax probably for lambdas, and used with receiver-based function types. All right, then you have callable references. So this is a function is odd, and you can do predicate from int to boolean. So the predicate of 3 is true, and this is the same as declaring is odd to 3. So let's do this. You can refer to existing functions. This is the same as doing is odd to 3. Yep. As you see here, maybe here we can add a space. first int 42 is 42. Great. Then reference to properties. You can do something like size ref, then you pass in a list and you will take its size as output. So you can both refer to functions and to properties. Properties, right? Then constructor references. So you can also refer to a constructor. That's what it's saying. And in this case, you are going to reference to the constructor, and this way you can access its functions. So that's nice thing. This matches is part of regex class. This function matches is part of regex class. So you see, yeah, this is a public class and it has the matches function, and that's why we can refer to this. It can be used also as infix notation. So I think you can do something like this. Yeah, looks like. We have seen this in the last lesson. When you use the infix, you can use this notation. Then you have bound callable references. So basically, yeah, you can refer to a function of a class. So our class is string, and we're referring to the class function. So yeah, in particular, it's a reference to hello to string method. All right, this is a nice explanation. We have still a lot more to do here. So we have you can define your own class that behaves like a function. And the way to do it is to create a class that returns a function, and you override the invoke operator or the invoke function, and you specify what the function has to do. This way, when you create your transformer, it will have to return it will have to have the function syntax. So take argument int and return int, and you instantiate the class, and then you can call transformer, because this is a function actually, and give it an input, and this will give the output as integer. So let's do this. Just all result int is going to be result int, and as you can see, it's of type int. It's directly, the compiler knows that the return type is int. Type inference, so yeah, it can infer the type, okay, automatically. We don't need to specify that. Function types with and without receiver are interchangeable. So repeat fun. So you can both have two types as arguments, or one type as argument, and sorry, when this was called, how did they call it? Receiver type, and then so receiver object and parameter. So the receiver object is string and the parameter is int, but you can specify them as parameters, as two parameters, and that's going to be fine as well. They are interchangeable, as you see here. So run transformation, repeat result, repeat fun is going to be the same as if you pass here two params. So yeah, I would just do it with params. And as you see, it's the same. And then if you assign an extension function without specifying its type, Kotlin assumes it has no receiver. So for example, run inference, inferred as string int, okay, to string. The correct syntax here is to specify the receiver. So you need to specify that it has an input of type int. So let's try. Doesn't seem to have issues, but oops, I have so yeah, probably these two have different meanings. Yeah, as you see, it says unresolved reference. If you don't specify the argument and you are using this syntax, it's going to complain. Right. Perfect. So we have done all we could do here. And now we're going to pass to invoking a function type instance. So a value of function type can be invoked by using its invoke operator or just f of x. So it's going to be the same if you use .invoke or if you use parentheses. If the value has a receiver type, the receiver object should be passed as the first argument. Another way to invoke a value of a function type with receiver is to prepend it with the receiver object as if the value were an extension function. So here they're passing string, okay, string plus, int plus. If you do this dot invoke or without invoke, it's going to be the same. You can use the extension like or call or also the normal call. One thing I would like to know is why they have created .invoke. So why and which So of course, you need a reference to the invoke function itself. So if you're doing reflection or passing the invoke function somewhere explicitly, like double invoke, then you might need to to use the invoke. Or if you want clarity in edge cases, for debugging clarity. Okay. Reflection or method references. So you should actually, practically, it's better not to use the invoke. Inline functions, okay, we'll see these later. Lambda expressions and anonymous functions. So they are function literals that are functions that are not declared, that are passed immediately as expressions. Okay, so I have some allergy, so I had to mute. Consider the following example: max strings. So we're passing strings, and then this is going to take A and B and return if A is length is less than B length. The function max is a high order function, as it takes a function value as its second argument. So this is the second argument, and it's a high order, it's a function. This second argument is an expression that is itself a function, called a function literal, which is equivalent to the following named function. So compare A and B, it returns a boolean. Okay. Then you have the lambda expression syntax, which is what we have seen already. The full form is as follows. A lambda expression is always surrounded by curly braces. Parameter declarations, okay, may have optional type annotations, and the body goes after the arrow. If the inferred return type of the lambda is not unit, the last expression inside the lambda is treated as a return value. So if you leave all the operational annotations out, what's left looks like this. Okay, perfect. Passing trailing lambda. So this means that according to Kotlin, if the last parameter of a function is a function, then a lambda expression passed as the corresponding argument can be placed outside the parentheses. So yeah, you can place the lambda and use it as a trailing lambda outside the parentheses if it's the last argument of the function. It is very common to have only one parameter. So if the compiler can parse the signature without any parameters, the parameter does not need to be declared inside the and the return can be omitted. So the parameter will be implicitly declared under the name IT. So for example, this filter will check if IT is greater than 0, and if it is so, then it will return the boolean. So you don't need to specify neither any parameter inside here or any return type, which is awesome if you want to code quickly. You can explicitly return a value for the lambda using the qualified return syntax. Otherwise, the value of the lost expression is implicitly returned. Therefore, the following snippets are equivalent. So you make a filter, it is greater than 0, should filter, blah blah blah. This convention, along with passing a lambda expression outside of parentheses, allows for LINQ style code. String, so filter, sorted by, map, so you can combine multiple lambdas, which is very nice to know. This coding convention allows for LINQ style. So let's see what's LINQ style. Language integrated query. So is the name for a technology based on the integration of query capabilities. Okay, so let's go on reading, then we will recap everything, because we should have just this. Yeah, so return, okay, underscore for unused variables. So you can specify the underscore for unused variables. That's okay. The structing in lambdas is described as part of the structing declarations. I think we did not, okay, we did not talk about this yet. Anonymous functions. So the lambda expression syntax above is missing one thing, the ability to specify the function's return type. So in most cases, this is unnecessary because the return type can be inferred automatically. However, if you don't need to specify, if you do need, sorry, to specify it explicitly, you can use an alternative syntax, an anonymous function. An anonymous function looks very much like a regular one, except its name is omitted. So its body can be either an expression or a block. Right, the parameter and the return type are specified in the same way as for regular functions. The return type inference for anonymous function works like for normal functions. The return type is inferred automatically for them with an expression body, but it has to be specified explicitly for anonymous functions with a block body. I don't know why you should use them. When passing anonymous functions as parameters, place them inside the parentheses. The shorthand syntax that allows you to leave the function outside the parentheses works only for lambda expressions. Another difference between lambda and anonymous functions is the behavior of non-local returns. So a return statement without a label always returns from the function declared with the func keyword. This means that a return inside a lambda expression will return from the enclosing function, whereas a return inside an anonymous function will return from the anonymous function itself. So let's do this. What is the advantage? So it's a function without a name. It's similar to lambda, but with more control, especially over return types and control flow. So let's see the advantage. The advantage is that the return type is explicit. Block bodies are allowed, okay. You have local returns. So you can return an anonymous function. Sorry, returning an anonymous function only exits that function, not enclosing one, unlike lambdas, to avoid accidental early exits. So safer in callbacks or nested control flows. Familiar syntax, more similar to regular functions, okay? So the advantage is, yeah, basically you're giving, the function name is going to be add. So yeah, let's create an example here. We already have this one as an example. So yeah, body block allowed, and um, okay, so then you have the cons, more verbose, no trailing lambda syntax. So you cannot place it outside the parentheses of a function call, less idiomatic. Can't be used inline with receiver. Let's see what less idiomatic means. Okay, so yeah, it doesn't align with best practices. Let's say syntax friendly, so it's less syntax friendly. I will try to copy this in code. Oh, need to take this. I always forget if there is a way to comment this. Ah. All right. So let's go on with the lambdas. Closure. A closure expression or anonymous function can access its closure, which includes a variable declared in the outer scope. The variable captured in the closure can be modified in the lambda. So what is returned by filter can be modified later inside oh, the closure is probably this variable, the sum, and it can be modified inside the lambda function without issues, and then you can return this variable without any side effect. Function literals with receiver. They can be instantiated with a special form of function literals. As mentioned above, Kotlin provides the ability to call an instance of a type function type with the receiver while providing the receiver object. So the receiver object passed to a call becomes an implicit this, so that you can access the members of that receiver object without any additional qualifiers, or access the receiver object using this expression. This behavior is similar to extension functions, which allow you to access the members of the receiver object inside the function body. So yeah, basically you can access what your receiver, which is, in this case, it's this object right here, which is an integer. So an example of a function literal with receiver along with its type, where plus is called on the receiver object, is this one. The anonymous function syntax allows you to specify the receiver type of a function literal directly. This can be useful if you need to declare a variable of a function type with the receiver and then to use it later. So actually this was wrong probably by ChatGPT, because you could actually use an anonymous function with arguments and with the receiver type. Like here. Sum 3 and 4. Lambda expressions can be used as literal functions with receiver when the receiver type can be inferred from the context. One of the most important examples is type-safe builders, which we will see in the next lesson. Oh, sorry, I have placed my hand on the microphone. So, for example, this is lambda with receiver begins here, so calling a method on the receiver object. So you're calling this body function inside the lambda, and the fact is that here you're returning the HTML, and so it will do basically this dot body on its own. And because the body is part of class HTML, this is also used in Ktor, as you will see here. So basically you have the HTML object and you're passing a lambda here with head title. These are all functions which take as arguments other lambdas, or yeah, maybe there are, it depends, they might be classes, not functions, and they allow you to pass a function, a lambda function. Yeah, it's what they're saying here. So it's like the receiver can be accessed through the this dot keyword. And the advantage of this is that it is possible to create type safe and statically typed builders. And we will see this later on. All right, so let's do a big recap of all of that. Then we'll take a pause and go to inline functions, which should be quicker. So let's take a close recap. These. Might be too long for ChatGPT. Not too long, okay. Anonymous function, closure, function leaders with receivers. So I'll just go through the things that we did not mention that much. Probably this one. Okay, let me check max. Right, this example is not complete. And meanwhile, so this one is clear. This one is clear. So you can say, I don't want to use parameters, some parameters anymore. Map of, I don't know, A to 1, B to 2. So for example, you can have, this should be the key and this should be the value, right? So if you don't want to use the key, you just say underscore, I don't want to use the key, and you just print the value. That's okay. So yeah, if it's one parameter, okay, this one is not needed. You can use closure like this. So ints are maybe 1 through 134, 135, sorry. Sum of ints. Right. And then we have the function literals with receiver, which was like this one. Repeat fun anonymous, and this should be equal to fun, then string dot other, and it should return a string, and the syntax here should be something like return so we have other, which is our parameter, so repeat return. Yeah, it shouldn't be with equal, probably. All right, so this is the same syntax, but for anonymous function leader with receiver. So a full example of that is this one. So we need to take a list of strings and find the longest string, string.max with or null, compare by length, and this is going to be an example of how was it called? Function literals. Functions not declared with a name but pass directly as expressions. So let me see here. It's going fleet. Let's remove this one and let's have this example. So it takes the longest string. Basically what it does is it takes the list. We can directly take this one right here and take max or null, max with or null, and this is a function that takes a comparator, and as comparator we take the length. So we say compare by, which is another function that compares A and B with a specific syntax. So for example, it returns 0, -1, or 1. If they are equal, it returns 0. Otherwise, it will return null. So let's try and run it. It should return longest string, strawberry. So it did its job. Compare by its length. So it takes probably this gives the length. So basically compare by will compare A and B length, and it should return one or the other. Okay, so the job is done here. As you can see, this is the max function. It will use the comparator.compare. If it's less than 0, it will say the maximum value is E. which is the element, and the element is going to be an item of the list, so IT. Oop. Iterator done next. So that's how it works, and it stores the max and returns it later. Okay. So what else? We do just a quick pause now. I will open a website, and I will put a little bit of pause time. So this is my website. If you want to check it, you can book a meeting with me if you want. Like if you're looking for a consultancy on Kotlin. And here I had started to put in some lesson recaps, but then I stopped updating them. If you want to have them updated, please write me in the comments, and I will keep on updating them. So I will just leave the page here for a few minutes. Thank you. Okay, so we're back again, and we'll have a look at as promised, at the inline functions, and then we'll see the remaining stuff like builders and operator overloading next time. And then we're going to jump into more fun stuff in the future. So this we are almost done with the basics of Kotlin, and I'm very happy about that we managed to go almost through all the concepts. And then, yeah, before going to more advanced concepts like Kotlin multi-platform in the future, we'll have a big recap of everything. I hope I can manage to pull out that one. So let's go on with the inline functions now, and let's read what they have written here. So using high order functions imposes certain runtime penalties. Each function is an object and it captures a closure. A closure is a scope variable that can be accessed in the body of the function. Memory allocations and virtual calls introduce runtime overhead. So that's the disadvantage of that, but it appears that in many cases this kind of overhead can be eliminated by inlining the lambda expression. So the functions shown below are good examples of this situation. The lock function could easily be inlined at call sites. So consider the following. You are passing a function to another function, lockL. Instead of creating a function object for the parameter and generating a call, the compiler could emit the following code. So it could say l.lock try to run foo, and then and l.unlock. To make the compiler do this, the mark lock function with the inline, you should mark the lock function with the inline modifier. So the lock function, in order to do this, should be marked with inline. And this, the inline modifier affects both the function itself and the lambdas passed to it. All of those will be inlined into the call site. So inlining means that the function is executed, and then the other function is that is passed, it will be executed, and finally it will be unlocked in case the passed function fails or not. So inlining may cause the generated code to grow. However, if you do it in a reasonable way, so avoiding inlining large functions, it will pay off in performance, especially at megamorphic call sites inside loops. So this is more of an advanced concept, I would say. If you don't want all of the lambdas passed to an inline function to be inline, mark some of your function parameters with the no inline modifier. So if you want to really specify that that you don't want them to be inline, you can do that with no inline. Inlineable lambdas can only be called inside functions or passed as inlineable arguments. No inline lambdas, however, can be manipulated in any way you like, including being stored in fields or passed around. Non-local jump expressions. So in Kotlin, you can only use a normal unqualified return to exit a named function or an anonymous function. To exit a lambda, use a label. A bare return is forbidden inside lambda because a lambda cannot make the enclosing function return. So you cannot make a return on the primary function foo, but if the function the lambda is passed to is inline, the return can be inlined as well, so it will be allowed. So if the function you're passing is inlined, then you can have a return and return for the foo function. Such returns are called non-local returns, and this sort of construct usually occurs in loops, which inline functions often enclose. So, for example, if you are passing if this sort of function usually occurs in loops, which inline functions often close. So if you have a loop and you want to exit this loop, you can do so with a return located inside the lambda, and this will exit. Yeah, this is our lambda, as you see here, and this will exit on the main function that you have. Note that some inline functions may call the lambdas passed to them as parameters, not directly from the function body, but from another execution context, such as a local object or a nested function. In such cases, non-local control flow is not allowed in the lambdas to indicate that the lambda parameter of the inline function cannot use non-local returns. Mark the lambda parameter with cross-line modifier. Okay. Break and so break and continue. Similar to non-local return, you can apply also break and continue to jump the expression. Rectify type parameters. Sometimes you need to access a type passed as parameter. So for example, here it's taking p parent while p is not null, and class Z is instance of p equals to p dot parent. Here we'll cap a tree and use reflection to check whether a node has a certain type. It's all fine, but the call site is not very pretty. Tree node find parent of type. Then here passing the type, okay. And basically find parent of type, okay. So it's taking the p.parent. Better solution would be to pass a type for these functions. You can call it as follows. To enable these, you need to use rectified parameters to make it accessible inside the function. Okay, as you see here, you had to use class.instance of p, and instead, if you use rectified, you can directly reference the type t, which is better. And as you see here, you don't also need to suppress the checkcast. So let's go to inline properties. Inline properties can be used on accessory properties that don't have backing fields. You can annotate individual property accessors. Restriction for public API inline functions. When an inline function is public or protected, but it not part of a private or internal declaration, it is considered a module public API. And this imposes certain risks, of course. To eliminate the risk being introduced by a change in non-public API of a module, public API inline functions are not allowed to be used to use on non-public API declarations such as private and internal. All right. Okay, so let's try and do a recap with ChatGPT. Maybe up to here for now. Let's see if it takes it all. Recap the following. So high order functions create function objects and capture a closure. This adds memory and performance overheads. The solution is to use an inline annotation that tells the compiler to insert the function body directly at the call site, removing the overhead. So the example is this one with lock and modifiers with inline. No inline prevents specific lambdas from being inlined. For example, if you have a very complex function, cross inline prevents non-local returns from lambdas. So this allows you to, you should use it when a lambda is invoked in different concepts, such as inside a runnable. Normally, return can exit from lambda, but inline functions can do it because they're inlined inside the existing function. You can use rectified parameters. Normally, generic types are erased at runtime. With inline plus rectified, you can access type information, which is useful, and you don't need to use reflection from Java. So as we have seen here, this example was using reflection with Java, but in fact, you don't really need to use it. You can use directly with rectified T, you can refer to the T type directly. Inline properties, you can mark getters and setters as inline, okay? And then here you have public or protected. Inline functions can't reference private or internal code. To allow internal code use, you can use published API. So let's inline properties advantage. When you don't need a backend field, here's why and when there are advantages. So for example, inlining removes method call overhead. The getter and setter is directly inserted at the call side, avoiding a function call. For example, current time. If you inline this will generate now equals to current time method call, and compiler turns it into system current time millis, and it inlines it directly. Cleaner code. All right, so I think we're done with today's lesson, and I hope you enjoyed it. And next time we're going to see operator overloading and builders. Then we will see the remaining concepts that we have here. Some of them we have already addressed them. We did not address certainly asynchronous programming and coroutines, which is very useful as well to know. And then we're going to see our platform concepts and other stuff that we did not address specifically. Okay, so I hope you guys enjoyed it, and if you liked it, please like, comment, subscribe.